Today we are going to see what the differential of a function is. We have a function f and we define the increment of the function as the difference of the values of the function in 2 points that are quite close, very close, like point x and point x plus increment of x. And obviously this increment depends on the point x that we are taking, so we have to fix a point x. Let's call it x0. So the increment of a function in a given point x0 is the difference between the values of the function in x0 and in a point that can be taken quite close or very close to x0 plus increment of x. Now if we go to differentials, we are going to do the same. The differential of a function in x0 is exactly the same, but in this case we take increment of x infinitely small. Mathematically we can represent that with the limit, taking the limit, so we can define the differential of x as the limit of f of x and 0 plus increment of x minus f of x0 when increment of x tends to 0. So a differential of a function is the same as an increment of a function, but when the increment of the variable is taken to be infinitely small. Well, obviously this limit is going to be always 0, but the important thing is not the value of this limit, but comparing this limit with comparing the differential of f with the differential of the variable. The differential of the variable x can be taken to be a function as well. So the differential of x can be taken in the same way. Can be defined as the limit when increment of x tends to 0 of x0 plus increment of x minus x0. In this case the function we are considering is x, the function x, which is the identity function that matches every real number with itself. Obviously x0 and x0 cancel out, so we have just the limit when increment of x tends to 0 of increment of x. So differential of x is just an increment of x considered very small, infinitely small. But as I said, what is important here is comparing this the ratio between these two differentials, the differentials of the function and the differential of the variable. Differential of the function and the differential of the variable, they are both taken at a certain point x0, and replacing the differentials by their meanings as we have defined them, and what we get here is the derivative of the function at the point x0, which means that the ratio between both differentials, the differential of the function divided by the differential of the variable, is a different way of writing, of expressing mathematically the derivative of a function. It is an equivalent way to express the derivative of a function, which is very much used, especially by physicists. And we are going to make use of it to make some demonstrations, some proofs much easier.